This video is more with exponents and scientific notation. So again, we talked about those 7 exponential rules that were learned in the past 2 lessons. Now we're actually going to use those exponential rules to help us multiply and divide scientific notation. So both of these forms are in scientific notation. Again, notice the a, or the first number for both of them, is between 1 and 10. And the exponent will tell you how many times that number is being multiplied by 10. Again, the negative exponent means a super small number, and the positive exponent means a bigger number. So in order to multiply these two, we're going to break it up into individual parts, or stuff I'm able to multiply. So I know when I look at this, I'm able to multiply any sort of number I see. So I'm able to multiply 8 and the 2.7. But then I also realize here that I can multiply the 10 to the negative 6 and the 10 to the 7th, because the bases of 10 are the same. So I have 10 to the negative 6 that I am able to multiply by 10 to the 7th. Again, all we're going to do here is multiply them out. So 8 times 2.7, 8 times 2.7 gives me 21.6. So 21.6. And I know I'm multiplying that. So I'm going to put the little X for multiplication. I mean, you can put the star for multiplication. Doesn't matter. It's all same notation. And then I know I'm going to have 10 to the negative 6 times 10 to the 7th. Instead of doing that in our calculator, since I have a similar base, I'm able to use these exponent rules. Remember, I'm just multiplying these two, so I'm going to use the product rule. The product rule says when I'm multiplying two exponential expressions with the same base, all I do is add the exponents. So negative 6 plus 7 gives me 1. Don't forget, though, that that base of 10 still stays there. So we're close to having our answer for these two scientific notations being multiplied. We have a solution here, but here's the key thing you need to focus on now. When you look at this, remember, the a, or the first number, needs to be between 1 and 10. Is 21.6 between 1 and 10? No, it's not. So we need to rewrite 21.6 in scientific notation. So in order to do that, remember, the number has to be between 1 and 10. So the only possible way to make this number between 1 and 10 is make it a 2.16. So in comparison to these, notice the number actually got smaller. So I know on my exponents, I'm going to have a positive. I mean, the number did get smaller, so the positive here, because if I have a positive, that makes going to make the number bigger. How many times did you move the decimal? You moved it once, so your exponent will be 1. But then don't forget, we have this times 10 to the first at the end. So one thing I need to make sure we understand here, this 21.6 is rewritten as 2.16 times 10 to the first. Because again, your a, or your first value, cannot be greater than 10. It has to be between 1 and 10. So these two are equivalent, and that 10 to the negative first stuck around at the end. But one last thing we need to do here, we do need to finish simplifying this. So when we simplify this, we know we have the 2.16 that can't be multiplied by anything else. But now we want to combine that 10 to the negative, or sorry, 10 to the first and 10 to the first. Notice the bases are the same, so we're using the product rule. The product rule says add the exponents. So 1 plus 1 gives us 2. So if I simplify these two scientific notations being multiplied, I get 2.16 times 10 to the second. One way to check this, I mean, you're able to do these on your calculator. So I have the quantity 8, and then this button here that says EE, that means scientific notation, exponential expression. So that's an exponent of -6. So this is how we type in scientific notation into the calculator. So 8 times 10 to the -6 is the same thing as 8e to the -6. I'm going to multiply that by 2.7. Again, times 10 with an exponent of 7. The e just means exponent. The EE stands for exponential exponent. So that way we know it's in exponential notation or scientific notation, and the E, second E, is just the exponent. Notice it doesn't give us our answer in scientific notation, but we do have 216. If you want, you can change this back to scientific notation, which will give you the exact same answer as what we have here. So 216 is the same thing as 2.16 times 10 to the second, but most of the time when your problem is given in scientific notation, they want your answer in scientific notation. All right, so we know how to multiply scientific notation. Now let's talk about dividing scientific notation. This is going to take a very similar form to what we just did in multiplying. We're going to divide what we can. So we're just going to divide the numbers. We have just numbers here that we're able to divide. And then we're going to divide the base 10s and their exponents. Remember, the base is 10, so we can just divide those. All right, so we pull up our calculator to do 1.2 divide by 3.5. And yes, we get some crazy decimal, but we're going to approximate this. Again, in the MyMathLab program, please make sure you're rounding to what the program is asking you to round to. Since there's no directions here, I'm just going to round to 2 numbers after the decimal. So I know when I divide out the 2 numbers, I get 0.34. Again, 0.34. The 2 keeps the 4 the same. And then when we divide out the exponential expressions, the 10 to the 9th and the 10 to the -10th, we're just using the quotient rule. The bases are the same of 10. So we subtract the exponents. So I have 9 minus -10. 9 minus -10. Notice it gives me 19 because the negative and the minus become a plus. So really you're doing 9 plus 10. So I have 0.34 times 10 to the 19th power. Again, always double check to make sure here that your scientific notation is correct. So your first value, or the A, needs to be between 1 and 10. Is 0.34 between 1 and 10? No, it's not. So I need to write that 0.34 in scientific notation, and then I need to add on that times 10 to the times 10 to the 19th at the end. So the only way to write 0.34 in a correct form where the A is between 1 and 10 is 3.4. And since I'm going from smaller to bigger, I will have a negative exponent. You can also think of it as this form, when we're writing in scientific notation, will actually be getting smaller, so that's why you have the negative exponent. It's a matter of determining what that negative exponent is going to be. So from 0.34 to 3.4, how many times did you move the decimal? You moved it once. Again, this 3.4 times 10 to the negative first means the number will be getting smaller because of the negative, and you're moving that decimal one place. So if it's getting smaller, you're going to move it to the left, which gives me with the 0.34. But then I also have my times 10 to the 19th power in there. So again, to make sure this is 100% clear, the 0.34 is the same thing as 3.4 times 10 to the negative first, just notation. And then the 10 to the 19th just kind of came down. But the last thing we need to do is we need to combine what we can. We know we can combine these 10 powers. So when we're combining those powers of 10, we get 3.4 times 10 to the, notice this is the product rule because I'm multiplying two exponential expressions with the same base. So I add the exponents. Negative 1 plus 19 gives me 18. Again, a nice way I always like to check my answer is in the calculator. That's why these are available. So I have 1.2 times 10 to the 9th. Remember, instead of typing in the times 10, I can just put that e in for an exponent of 9. And I'm going to divide that by 3.5 times 10, or e, to the negative 10th. And notice this time it does give you scientific notation right away. We have the 3.4, which is, again, this is an approximate value. And we have the e, 18. The e stands for times 10, and the exponent is 18. So again, these are exact same form. So sometimes the calculator will give you scientific notation if it's a large enough value or a small enough value. And like we saw in the last problem, sometimes it won't. So don't always rely on the calculator. Make sure you know how to change to and from scientific notation.